Hi. This instructional video is about simplifying radicals. Simplifying radicals. On numbers 1 and 2, we have a square root. Even though we don't see it, it is always implied that if you have a radical without any root indicator, that this is going to be a 2. It's a square root. And numbers 3 and 4, they're going to be cube root. So on number 4, for example, it says 4 times, the coefficient is the 4 times the cube root of 192. So how would you do numbers 1 and 2? Why don't you try it first? Go ahead. All right. So when we talk about square roots, by the way, it's always good to quickly do a review of what a square root and a cube root mean. Square root literally means we're talking about a square. So if we're talking about a square with an area of 4, remember it's a square defined by the 90-degree quadrilateral where all the sides are congruent. So what I'm asking is an area of a square that has a 4 units. I'm asking what are the 2 dimensions, what are the root dimensions that would give you an area of 4? The formula, of course, area equals length times width. And since the area is 4, you know, given that it's a square, see those 2 notches? Means they're congruent sides. They have to be 2 and 2. So the sides are 2 and 2. So what is the root of that square? It's 2. And that's what square root means. Likewise, when we talk about cube root, we literally mean cube. A cube with the 3 dimensions that are congruent. So if I told you, or if I asked you, if you had a volume of a cube that is 8 units, given that it's a cube, I'm asking you, what are the dimensions that are congruent that will give you a volume of 8 unit cubed? Well, in this case, it's going to be 2 as well. And that's what square root and cube root are talking about. What are those root dimensions? So, on number 1, 96 is not a perfect square. There is no 2 exact identical number that you would multiply to get a 96. So the best way to do it, let's do this the easy way, or the most fundamental way. Let's identify all the prime numbers that you will multiply to get 96. And since the last digit on this one is a 6, is an even number, the smallest prime number that you would think of is a 2. So 2 times 48 would give you 96, wouldn't it? And you could further break that down. Again, 8 is an even number, so 2 goes in there as 24. And 24 is 2 times 12. 12 is 2 times 6. And 6 is 2 times 3. And you stop because we have come down to the last prime number. And you realize, wow, we need to multiply these prime numbers together to get a total radicand of 96. So since it's a square root, I'm asking you, what are the 2 identical sides that you will multiply? Well, I see an identical number here. So 2 comes out. Here's another identical 2. And whatever comes out, you're going to multiply it. Now, these don't have an identical number. So what do? They stay inside the radical, and you just multiply them back. 2 times 3 is 6. So this, in fact, becomes 4 square root of 6. And that is a simplified form of that radical. And number 2. Now, if that was a 1,600, we know that the square root would have been 40, but it's only 160. So you have to do that prime factorization again. But now that we know how this works, let's quickly think of a perfect square number that you will multiply to get 160. And that will be 16 times 10. Because I know 16 square root is going to be 4. 10 is going to be the residual number that stays inside the radical. So since square root of 160 is like saying 16 times 10 times the 2 coefficient outside, the 16 comes out as a 4, and whatever comes out multiplies with whatever's outside already. So that's going to become an 8. What stays in is the 10. See? Did you see how that worked? All right.